Welcome back, students. Today we are going to start our final section of first semester of algebra, and that is working with inequalities. So an inequality is basically going to be treated the same way as we would when we solve equations. Only difference is with equations, you have to have an equal sign, but with an inequality, you're going to have a less than sign, a greater than, a less than or equal to, or a greater than or equal to symbol. All right, but other than that, there's really only one other difference in the fact that when you go through and you solve, when you go through and you solve, when you're working with negative values. So for example, if I had 5 and I compared it to the number 6, 5 compared to the number 6, I definitely wouldn't use the equal symbol. Those are not the same numbers. But what symbol would I use? Well, I know that 5 is less than 6. All right, but what if I change that? What if instead of having 5 and 6, what if I change that to be -5 and -6? Well, they're still not equal, but now this time we're going to flip that inequality symbol around because -5 is greater than -6. All right, so as you go through and you solve an inequality, you're going to solve it just like you would an equation. The only difference is if you ever multiply or divide by a negative value, you need to remember to flip the inequality symbol around. One other difference between an equation and an inequality is that an inequality is going to give you a range of solutions versus when you solved an equation, you would just get something like x is equal to 2, which meant that 2 was the only number that you could plug in to make a true statement. What we're going to have with an inequality is a range of values, so options for what numbers we can plug in to get a true statement. So let's go ahead and just get started with some examples. So for this first example, we have 2x minus 6 is greater than 8. Had this been an equal sign, what we would do is we would just split the left-hand side from the right-hand side. We'd make sure that both sides are as simplified as possible. And then we'd find the variable and figure out what are we doing to that variable and how are we going to undo whatever we are doing to that variable. So in this case, we have x, and it's being multiplied by 2. We also have a -6, which means we are subtracting. So as we go through and we solve, we need to work backwards. We have to undo what we would have done last. All right, so this -6 needs to go to the other side first, and since it's going to the opposite side, the opposite of a -6 would be a +6 on both sides. -6 plus 6 cancels out, and that leaves us just with 2x is greater than, and then 8 plus 6 gives me 14. Now I get rid of the multiplication. The opposite or the inverse operation of multiply is divide. So I'm going to divide both sides by 2. 2 divided by 2 cancels. That leaves me with x over here. Since I'm dividing by a positive number, it means I keep the same inequality symbol. And then 14 divided by 2 is going to give me 7. So what this is saying is if I pick any number that is bigger than 7, any number that's greater than 7, if I plug it back into the original inequality, which was 2x minus 6 is greater than 8, I'm going to get a true statement. All right, so for example, what's a number that is bigger than 7? Well, 8 is. So I'm going to try x equals 8 and make sure that this is true. All right, so this is my way that I'm going to check my work. All right, so let's say x is equal to 8. What I'm going to do is I'm going to substitute that into the inequality for x. And that's going to give me 2. I'm going to replace x with 8. And then -6, is that greater than 8? Well, 2 times 8 is 16. -6, is that greater than 8? 16 minus 6 is 10. 10 is greater than 8. That's a true statement. All right, so 8 works. If I wanted to try 9, it would work. If I wanted to try 10 and so on, it would work. I don't even just have to use whole numbers. I could use also decimals or fractions. So if I wanted to do 7.5, since 7.5 is larger than 7, that would also make a true statement. All right, so because there's not just one solution, it's a range of solutions, what we normally do is we graph our solution set on a number line to show our reader what would work. What could we plug in? All right, so 7 is the boundary. if I plug in 7, let's see what happens if I plug in 7. So if I take 2 times 7 minus 6, 2 times 7 is 14 minus 6. 14 minus 6 is 8. Is 8 greater than 8? No, it's not, because it's equal to. All right, so this one didn't work. 7 doesn't work. But anything bigger than 7, so 7.1 would work, and so on. So 7's the boundary. So what I'm going to do is I'm going to put a point at 7. If it is going to be included in my solution, I'm going to use a closed circle at 7. So if 7 was a part of the solution, I'd be using a closed circle at 7. If it's not a part of the solution, I'm going to use an open circle. So in this case, it is not included in the solution, so I'm going to use an open circle saying, hey, it gets as close to this point as possible, but we don't actually include this point. So I'm going to use an open circle at 7, and then I'm going to think of numbers that are bigger than 7. Where are those on this number line? All right, and my number line actually doesn't extend over far enough. All right, but here's where 8 would be, here's where 9 would be, here's where 10 would be, and so on. And these are my solutions. All right, so what I would do is I would darken this part of the number line, because this, on the right side of 7, is where all of my numbers are greater than 7, which makes a true statement for my first inequality. All right, let's do another one. So for this example, we have 8 minus 2x is greater than or equal to 14. So I'm going to separate the left-hand side from the right-hand side. I figure out that both sides are as simplified as possible, and my variable x is only on the left-hand side. It looks like it's being multiplied by negative 2, and we also have a positive 8, which means that we have addition. So I need to get rid of the addition first. So how to get rid of a positive? There's no sign there. If you want to put it there, you can. How do you get rid of a positive 8? Well, the opposite of that would be a minus 8. So I'm going to minus 8 on both sides. 8 minus 8 cancels. And then that leaves me with negative 2x is greater than or equal to. I know I'm subtracting 8, okay, but anytime you add or subtract, you keep the same inequality symbol. Flipping it only happens when you do multiplication or division. So 14 minus 8 will give me 6. Now I'm going to get rid of my multiplication by dividing both sides by negative 2. Negative 2 divided by negative 2 cancels, and I'm left with x. Because I'm dividing by a negative, I need to flip my inequality symbol around. 6 divided by negative 2 is going to give me negative 3. All right, so what this is saying is if I pick any number that is less than negative 3 or equal to negative 3 and plug it into the original inequality, I'm going to get a true statement. All right, so for example, if I take negative 3 and plug that in, I'd have 8 minus 2, and then in parentheses, negative 3 is greater than or equal to 14. This is going to give me 8 plus 6 is greater than or equal to 14, and 8 plus 6 is 14. 14 is greater than or equal to 14, which is a true statement. So because negative 3 is a solution, what that means is on my number line, where I see negative 3, I'm going to darken it. I'm going to include it. I'm going to use a closed circle because negative 3 is my boundary point, and it's included, which means I'm going to use a closed circle for this solution. Now, am I going to shade in values to the left, which are smaller than, less than values, or am I going to shade in the values to the right, which are greater than values? All right, so if I am having trouble with this, pick one of these. It doesn't matter which one you do, and see if it gives you a true statement or if it gives you a false statement. So for example, if I try negative 5 into the original inequality, that gives me 8 minus 2, and then in parentheses, negative 5. I need to see what this comes to, and if it's greater than or equal to 14, it means it's a solution. So this is going to give me 8, and the negative 2 times negative 5 is positive, so plus 10 is greater than or equal to 14. 8 plus 10 is 18, which is greater than 14, so that gives me a true statement. So because negative 5 was a solution, I also want that included, okay, but it's not going to be the only one. It's going to also be negative 4, negative 6, negative 7, negative 8, and so on. So I would darken the left side of this number line. All of my values that are less than negative 3 would make a true statement. All right, so that's how you go through and you solve a multi-step equation to get your solutions. But as you can see, how I checked my work is very handy. So what we're going to do on this next question is we are going to have, okay? It's actually this exact same inequality, and we're going to see whether or not we get solutions by substituting these values into the inequality. We already see what our solution is going to be right here, so we should already know that 5 is not going to be a solution, because if I plug 5 in right here, 5 was not shaded, which means that it should not be a solution. But let's see what happens, okay? Why is 5 not a solution? So if I take 8 and then minus 2, I replace x with 5. What I need to see is that greater than or equal to 14. So this is the part that I need to check. And if you're not very good with the arithmetic, Desmos can do this for you. So just type in, make sure anytime you substitute you use parentheses, but type in that the original inequality was 8 minus 2, and then replace the x with parentheses 5. And then over here it's going to tell you whatever that simplifies to. So what this simplifies to is negative 2. Is negative 2 greater than or equal to 14? Well, no, that's false. All right, so that means that 5 is not a solution, which verifies that 5 should not be included in our solution set up here, which is why it's not in the shaded value. 0. Okay, based on what we have up here, 0 should not be a solution. Let's verify that. So if I type into Desmos 8 minus 2 and then in parentheses 0, I need to see what that simplifies to be. So all I'm going to do is go back and replace my 5 with a 0, and that gives me an 8. All right, so this says that 8 is greater than or equal to 14. Well, no, that's not true. So that would be a false. It's not included up here in the solution set, and here's why, because it would give me 8 is greater than or equal to 14, which is a false statement. All right, negative 3, we already verified that up above. How did I verify that? I did 8 minus 2, and in the parentheses I put the negative 3. Again, Desmos, if you're not comfortable with doing this on your own, just use Desmos to do it for you, and this gets me 14. And 14 is not greater than 14, but because of this or equal to symbol, 14 is equal to 14, that makes it so it's a true statement. All right, and then negative 5, that's actually the one that I chose up there as well. 8 minus 2, and then in parentheses the negative 5. So if I change this one to be a negative 5, that gives me 18. And we know that 18 is greater than 14, so that means 18 is greater than or equal to 14 is a true statement. All right. So that's how you can verify to make sure that you are right as you go through and you're doing these. Let's go back to solving some other inequalities. All right, so these are going to progressively get a little bit harder as we go. But again, we've already solved equations, so there's really not much more to it. Just remember that you get a range of values for your solution. The other really important thing to remember is that if you ever multiply or divide by a negative, you need to flip your inequality symbol around. All right, so I'm going to separate on my left-hand side from my right-hand side. My left-hand side, I have 5x plus 6. That can't be simplified. On my right-hand side, I have 8x plus 24, nor can that be simplified. But notice that when I said those, I had x's on both sides. We need to get the variable to one side of the inequality. So you can either move 5x or you can move 8x over. It does not matter. I always like to move the smaller one. So 5x is smaller than 8x, so I'm going to move 5x over. So the opposite of a positive 5x, even though there's no plus sign right there, it is a positive. So the opposite of a positive 5x is a minus 5x, so I'm going to minus 5x on both sides. Again, the reason why I'm doing opposite is because I'm going to the opposite side. So this gives me positive 6 is greater than 8x minus 5x is 3x, and then plus 24. So now the variable is in one spot, and it's being trapped with multiplication as well as addition. We get rid of what's unattached to the variable first, because that's what's easier to do in life, is to get rid of things that we're not attached to. And 24 minus 24 cancels out. That leaves us with 3x on the right-hand side. And on the left-hand side, 6 minus 24 is going to give us negative 18. I wasn't multiplying or dividing by a negative, so I keep the same inequality symbol. Now I have x and it's being multiplied by 3. The opposite of multiply by 3 is divide by 3. I'm dividing by a positive, which means I keep the same inequality symbol. 3 divided by 3 cancels, and I'm left with x. And then negative 18 divided by 3 gives me negative 6. So what this is saying is negative 6 is greater than x. Okay, so another way to say this is x is less than negative 6. These two are equivalent, or they are the same inequalities. Okay, these are the same inequalities. I know I flipped my inequality symbol around, but that's because I flipped what I had on the left side with what I had on the right-hand side. Negative 6 is bigger than x. X is smaller than negative 6. That's really saying the same thing. All right, so either way, however you want to think about it, negative 6 is our boundary. And it's saying that we have less than or greater than symbols, which means that negative 6, if we plug it into the original inequality, it's not a solution, which means we need to use an open circle. We will always use, okay, if we ever have a less than or a greater than symbol, we will always use an open circle. The only time that we're going to use a closed circle is when we get the or equal to, which means we will include those boundaries in our solution. So we're going to have an open circle at negative 6, and negative 6 needs to be the bigger value. So what are smaller values than negative 6? Well, that'd be negative 7 and so on. Smaller values are on the left side of your number line. So this would be our shading for what our solution looks like for solving this inequality. For this next example, it's actually a pretty tricky inequality to solve because when you look at both the left-hand side and the right-hand side, they are as simplified as possible. But we need to know to do one thing before we can kind of begin like we did the other problem, and that is we need to get rid of this fraction on the right-hand side because our variable is being trapped by this fraction right now. So the first thing that I'm going to do is to get rid of this fraction. The fraction bar means divide, and so the opposite of divide would be multiply. So what I'm going to do is I'm going to multiply by negative 2 on the right-hand side. But if I'm going to multiply by negative 2 on the right-hand side, that means I also have to take my left-hand side and multiply by negative 2. And since I'm multiplying by a negative, that means I need to flip my inequality symbol around. So on the right-hand side, a multiply by negative 2 and a divide by negative 2 cancels out, leaving me with only the 9x portion. And on the left-hand side, I need to distribute. I need to take 3x times negative 2, which will give me negative 6x. And then I also need to take negative 2 times negative 15, which is going to give me positive 30. All right, now it looks a little more like the other ones that we've been working on. Left-hand side and right-hand side are as both simplified as possible. I split the left from the right, and I have variables on both sides. It doesn't matter which one I move, but I usually always go for the smaller value, and negative 6 is smaller than 9x, so I'm going to undo a minus 6x by adding 6x on both sides. Minus 6x plus 6x cancels out. That leaves me with 30 is less than or equal to 9x plus 16x will give me 15x. And then x is being multiplied by 15. The opposite of multiply is divide. So I'm going to divide both sides by 15, and I get that 2 is less than or equal to x. Another way that I could say that is x is my bigger value, and it is greater than or equal to 2. All right, so both of these inequalities mean the same thing. I could write either one down. But now what I'm going to do is I'm going to get their solution set. I'm going to get the solution graphed. So 2 is the boundary, and it is included in the solution. If I wanted to, I could go to the original inequality, and I could type these in. Let's do that on Desmos. For my original inequality, I had 3x, so I'm going to replace that with a 2, and then minus 15. That gives me negative 9. On the right-hand side, I have 9x, so I'm going to replace that x with my it was positive 2. And then I'm going to divide all of that by negative 2. And that also gives me negative 9. So that gives me negative 9 and negative 9, which are the same thing. And so because it says or equal to, that means that negative 9 is equal to negative 9 would be a true statement. So 2 would be a solution. Now I need to think of what are my other solutions, and this is saying is that 2 is smaller than those other numbers that are solutions, or those solutions are bigger than 2. So what's a number larger than 2 or greater than 2? That'd be 3, 4, 5, 6, 7, and so on, which means that I would need to shade or highlight this region, this right side of my graph. All right, let's do a few more examples. Okay, again, progressively getting a little bit harder as we go. I'm going to separate my left-hand side from my right-hand side. And my left-hand side, notice it has parentheses, which means it's not simplified. So I'm going to get rid of the parentheses. That means multiply. And multiplying through, I'm going to distribute. 2 times 2r will give me 4r. And then 2 times positive 3 is going to give me a positive 6. Is less than or equal to, I still have 22. But then I need to get rid of these parentheses. So positive 8 is attached to this binomial. So what I need to do is take 8 times r, which is going to give me positive 8r. And then 8 times negative 2, which is going to give me a negative 16. All right, so my left-hand side is simplified, 4r plus 6. Those are unlike terms. They cannot combine. But on my right-hand side, I have a 22 and a minus 16. All right, so I still have positive 8r. So I'm going to go ahead and write down positive 8r. And then now I'm going to combine 22 with a minus 16. So the reason why I just combine and don't do opposite is because they are on the same side. So 22 minus 16 is going to give me a positive 6. All right, now I need to get my r terms on the same side. Doesn't matter which one I move. I think I'm going to move the smaller one because that's usually what I always do. So this is a positive 4r, so I'm going to minus 4r on both sides. A positive 4r minus 4r cancels out. So this leaves me with 6 is less than or equal to. And then 8r minus 4r gives me 4r. And then I still have a positive 6. All right, so on my right-hand side, my variable is being multiplied by 4, and it's being added with 6. So we need to get rid of the add 6 first. So the opposite of add 6 is minus 6. 6 minus 6 is 0, is less than or equal to 4 times r. The opposite of 4 times r would be divide both sides by 4. Since I'm dividing by a positive number, it means I keep the same inequality symbol. 0 divided by 4 is 0, and then 4 divided by 4 cancels, and that just leaves me with r. So this is saying that 0 is less than or equal to r, or I could say that r is greater than or equal to 0. These inequalities mean the same thing. So when I come down here to graph this, 0 is my boundary. I'm going to use a closed circle because it says or equal to, so a closed circle would make a true statement. 0 is a part of my solution. And now I need to think of 0 is less than these numbers, or these numbers are greater than 0. So what numbers are greater than 0? That'd be 1, 2, 3, 4, 5. So all of these values to the right are greater than 0. So I need to make sure that I highlight this portion of the number line. All right, last example. Here's my inequality symbol. So once again, I will separate my left-hand side from my right-hand side. And my left-hand side is far from being as simplified as possible. So what I'm going to do is first get rid of the parentheses by distributing. So negative 7 times k would give me negative 7k. Negative 7 times positive 4 would give me negative 28. And then I'm just going to leave the positive 11k because it wasn't inside the parentheses, which means it doesn't get included in the multiplication. Is less than or equal to, I still have 8k. And then this parentheses is attached to the 2 out in front, but that 2 is negative. So that's kind of tricky. Remember to distribute not just the number, but the sign in front of it. So that's going to be a negative 2 that I multiply by. So negative 2 times positive 2 will give me negative 4, and then that had the k with it. And then negative 2 times positive 1 gives me negative 2. So what I'm going to do now is go back and find like terms. So this is a minus 7k. This is a positive 11k. They're on the same side, so I'm going to combine them. So negative 7 plus 11 is going to give me 4k. And then I still have this minus 28 is less than or equal to. Then 8k minus 4k gives me 4k. And then I still have this minus 2. So now I need to get my variables on the same side of this inequality. 4 and 4, those are actually the same number, so it doesn't matter which one I move. Never does it matter, but it's usually easier to move the smaller value. All right, so it doesn't matter really, especially this time because they are the same value. So I'm going to minus 4k on both sides. A minus 4k cancels out, leaving me with a negative 28. I haven't multiplied or divided by a negative, so I keep the same inequality as I go. But this time, 4k minus 4k, that also cancels out, leaving me with a negative 2 over here. Remember, if you ever have your variable that cancels all the way out, if you're left with a true statement, you're going to come up with all real numbers. And if you're left with a false statement, then that means that there isn't a value that if you plug in, you get a true statement, which means that there is no solution. All right, so if it's a true statement, it means any number that you want, if you plug it into the original inequality, you get a true statement. So that means that it would be a solution. But if it's not a true statement, if it's false, then that means that there isn't any number that you can plug in that gives you a true statement to your original inequality. So we need to really think about this one, especially since we're working with negatives. This is negative 28. So think about that in terms of the number line. You're looking at 0, and then you're going 28 numbers to the left of it. Negative 2 is just 2 numbers to the left of 0, which means that negative 2 is closer to 0. Negative 2 is the larger value. This inequality is opening up to the larger value, which makes this statement true. That means pick any number that you want, plug it into your original inequality, and you're going to get a true statement. So that means that all real numbers are true. So that means that if we need to show what this looks like on a number line, we don't have any boundary points, so we are just going to shade everything. Had it been false and no solution, we would have an empty number line. But since it's true, it's all real numbers, that means we are going to shade the entire number line for our true statement. And there you have it. That is how you solve inequalities. Really, the only difference between solving an inequality versus an equation is don't forget that if you ever multiply or divide by a negative, you have to flip your inequality symbol around. The other difference is your solution. Your solution for an inequality gives you a range of values versus for an equation, it usually just gave you one single value. But that's really it. I hope this video helped.